Now we are going for worked example 3 now. Let's see what it says. The distribution shows the number of cars owned by each of the 30 families that stay in Brook Apartments. Okay, so here's the distribution. Fine. What does it say? Calculate the range. So anyway, we've been given a distribution. So when we get a distribution, remember, we have two types of distributions. First is we have a frequency distribution, then we have a probability distribution. So if I look at this, what does it give me? Number of cars in family, okay? Then number of families, F. This is frequency. I know this is frequency now. Number of families, how many, right? So this is the frequency. So that means this is a frequency distribution, right? It's a frequency distribution table. Okay, fine. Now what are they asking for? And now when I see that it's a frequency distribution, the second thing I'm going to look at is it grouped or ungrouped? Is the data in this frequency distribution grouped or ungrouped? I can see that it is ungrouped because look at your data. It is not in ranges to say 1 to something. It's just 1. Number of cars in the family, 1. So we want to see how many people own 1 car, 5. How many people own 2 cars, 6. How many people own 3 cars, 10. So we know exactly the cars that each person owns because the numbers are there. All right, so it's ungrouped. You can go and see the video on grouped versus ungrouped. You understand. Now let's see the first question. It says, find the range. So now we know that, let's put the solution. We know that range is equal to highest value. Okay, we write that. Highest value minus lowest value, right? That's the range, which is equal to, what is the highest value there? I'm going to look. Are we looking at the frequency? No, we don't look at the frequency. Frequency is not our data. Our data is the one on top, the number of cars. So what is the highest value of the number of cars? What is the highest number of cars? That is 6 cars. So it'll be 6 minus, what's the smallest number of cars that the people are owning at this apartment? 1. Okay, so nobody has no car, at least 1. 6 minus 1 become 5. So our range is 5. Okay, remember, range is the interval in which all things fit. So that means when you come from the person with the lowest number of cars to the person with the highest, they are separated by 5 cars. Anyway, now we go to number 2. Okay, so this kind of helps us know the spread. There are 5 cars. There's a 5 car difference between person with the lowest number of cars with the person with the highest. So now let's go. The mean number of cars owned by a family. Now we are on part 2, which is the mean. Now we know that if we are doing mean, we always go to our MF19. So I'm going to go to it. Here is our MF19. It's loading. Load. Okay, here's our MF19. So we know that the mean is this on this left side. That's the X bar, right? Is the mean. So here is our mean, X bar, right? And the first formula is when you don't have a frequency distribution. We have, so this is out. So we are using this second one. X bar is summation of XF over the summation of F. So we can go ahead and put that, okay? I'm sorry for this. I'm going to remove it. We can now say, sorry, it's loading. We can now say here that the summation, we can say X bar. First, we can put it next here to say X bar is the summation of XF over the summation of F. Now, what you do is when you take it, you put it right next to this. And you see, is your data grouped or ungrouped? If it's ungrouped like this, we don't have to make another table. You can go back to the other question I did on mean, and you can see when we're dealing with ungrouped data, okay, it is in a frequency distribution, but it's ungrouped. We don't have to make a table. So that means what we are going to say is X bar is summation of XF over the summation of F. We can put the formula right away, which is going to be, we start doing the summation of XF. Remember, X is 1, F is 5. So it'll be multiplying, right? So it'll be 1 times 5 plus, we go to the next X. X is 2 this time. F, the frequency is 6. So plus 2 times 6, right? Plus X times F again, which is 3. That's the next X, and its F is 10. So plus, in bracket, we say 3 times 10. Then plus, we go to the next 4 by 4, right? So it is 4 times 4. Then plus 5 times 3. Okay, that's the next one. So plus 5 times 3. Then the last one is going to be plus 6 times 2. Okay, so plus 6 times 2. And then if I want to put the frequencies now, I know that the frequencies are 5, 6, 10, 4, 3, 2. Okay, so it'll be 5 plus 6 plus 10 plus 4 plus 3 plus 2. which we can go and find. Now the solution, let's do it. 1 times 5 is 5, plus 6 times 2 is 12, plus 3 times 10 is 30, plus 4 times 4 is 16, plus 5 times 3 is 15, plus 6 times 2 is 12, all over 5 plus 6. We can now add that. So we can add the denominator, right? 5 plus 6 is going to be 11, plus 10, 21, plus 4, 25, plus 3, 28, plus 2, 30. So, and we've already been told that the family is a 30 anyway. So now we can go, we've just confirmed. So it's going to be 5 plus 12 plus 30. We're now adding the top, plus 16, plus 15, plus 12. Okay. Plus 12. It's 90. So it'll be 90 over 30, which means that our mean is going to be cancelled 3 into 9, 3. So our mean is 3 cars. So this is our mean, 3 cars. Okay, that's our X bar, 3 cars per family. Okay. Now let's go to the last bit, which is the standard deviation. So now that we know the mean, standard deviation is very easy, right? How do we find the standard deviation now? Okay, now for standard deviation, we have to make our table, right? I hope you still remember the table, but the table is not this. It's a little bit more complex than the first one. The first one only had x and x squared when we are dealing with data that is not in a distribution. But when we're dealing with data in a distribution, here's what it looks like. So you say x, then you say x squared, then you say frequency, and then you say x squared times frequency. So x squared, then frequency, then x squared times frequency. Let's put that. Because here's a tip. If you want to know why, how you will remember this, then let's go ahead and I show you. Let's choose. We want to do standard deviation, right? So which formula do we use? Well, if we want to do standard deviation, then we go to the table, MF19. Which one? Should we use the first one? The first one is out. Why is the first one out in this case? Because we have a frequency distribution. So the first one is out, right? Okay, so which one do we use if the first one is out? We use the second one, this one, right? And on the second one, we use the second one of the second one. So we use this one, right? That's the calculation version. That's the one we're going to use. Okay, that's the one we're going to use. X squared f over the summation of f minus x bar, right? So let's go ahead and let's put it. So it's going to be, sorry for this. Here. So we know that we are using standard deviation is equal to summation of x squared f, right? Let me see one more time. Summation of x squared f over the summation of f, right? Over the summation of f minus x bar squared. We put the square root. So just from here, I know that what are the things I'm going to need? I'm going to need the summation of x squared times f, right? So I'm going to need this x squared times f, right? So that means I should get x squared and then I should get x squared times f, right? So how do I get x squared? I start from x, then I can get x squared. Then I put f, I can now get x squared f, right? So let's go. Because you've seen this formula, because we have a frequency distribution, we have a table, so we have to use the lower one, right? Definitely. The top is for when we don't have, so we're going to use this one. So now it's just about finding the things now. Let's go ahead. What are the x values that we had? They're the 1, 2, 3, 4, 5, and 6. Okay, so it'll be 1, 2, 3, 4, 5, and 6. The number of cars, right? And then x squared, 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25, 6 squared is 36. Then now we go to f, the frequencies is 5, 6, 10, 4, 3, 2. Okay, 5, 6, 10, 4, 3, and 2. Then now we can get x squared times f. It'll be, we'll say 1 times 5 would get 5, 4 times 6 would get 24, 9 times 10 would get 90, 16 times 4 is 64, then 25 by 3 is 75, 36 by 2 is 36 by 2 is going to be 72, right? There we go. Now, once we have it like this, here's an important thing. When we have it, we are going to sum up the last 2 columns. We sum them up. Don't ever forget to sum them up. We know, if you know, that we used to sum x squared and stuff for the other one, but right now we are only summing f and x squared f. Okay, so this is going to be, if we sum this up, let's add them up. The last two, what are we going to have? 5 plus 6 is 11. So let me just add, these are 30 families, we've been told that. Then here we can add, we can say 5 plus 24 plus 90 plus 64 plus 75 plus 72, we get 330. So here we're getting 330. Then we can now say x bar is equal to, we can put the summation of x squared f over the summation of f minus x bar squared, square root of that, which is going to be, what's the summation of x squared f is 330 over, what's the summation of f is 30. We add the last two columns, never forget that. Then minus the mean squared. What is the mean? 3, cuz, so minus 3 squared. Then we'll get the square root of that. Now let's go ahead and do it. So 330 divided by 30, we get 11. So it's going to be the square root of 11 minus 9. Okay, because 3 squared is 9. So it's the final answer will be root 2, which we can say square root of 2. You'd get 1.41. Okay, so the standard deviation is like 1.41. This is the standard deviation, and you have your final solution, and you are done.